Well, hello friends. Here we are, halfway through our finals review week. We are looking at our identities today. You're going to take your mini quiz on identities, and then your homework tonight is non-calculator part, just 40 to 49, looking at our inverse trig option. So we're narrowing it down, just kind of getting close to the end. Hopefully you guys are doing okay. I'll be back tomorrow if you have any questions. So just wanted to make sure we're all on the same page here. We're halfway through our week. One more mini quiz and just a little bit of homework tonight. So what I want to do is go through what you guys did for homework last night and make sure we just kind of touch on and clarify any questions. So first thing I want to talk about are these co-functions. I know we did this actually on Monday, but just to touch on it again. So we have sets of co-functions. Tangent and cotangent are a set of co-functions. Sine and cosine are co-functions, and then the reciprocals. So cosecant and secant are co-functions. Now these expressions are equal to each other when the angles are complementary. So sine of A is equal to cosine of B only when A and B are complementary. Same thing with cosecant, secant, and like we see here, same thing with tangent and cotangent. These expressions are equal to each other when they're set up with their co-function pairs and when the angles are complementary. So this allows us to rewrite expressions that we wouldn't know how to evaluate without a calculator in a different function that might be more useful to us. So just wanted to make sure we touched on that. It says, know all the sum and difference and double angle identities. Hopefully you guys studied this last night. Like I told you, it should be written on the back side of your orange unit circle. You definitely want to know your identities. Okay, so just to practice, if we're looking at our cosine, so the difference of our cosine identity. So what we do for cosine is it's cosine, cosine, sine, sine. And it is the opposite sign of what's written in the original function. So since this is x minus 34, we put a plus sign here. So for cosine, it's the opposite. And then the first angle goes in the first spot, the second angle goes in the second spot. So if we were to expand this out, it would look like this. Now, of course, what we were seeing more often were these angle values were ones that we could evaluate, so we could keep going further and simplify. But for this one, we're just practicing how to use the identity. Okay, so speaking of double angle identities, cosine of 2 theta was a special double angle identity because it had 3 versions of the identity. They're all related, but slightly different. Oh, this should say sine squared of theta, sorry about that. And remember, when we're subtracting, order matters, so make sure your cosine squared is first. All right, so let's see how we would use, here we have an example of sine of 3 pi over 2 plus x. So this is the sum identity here. So sine of 3 pi over 2 cosine of x. So here we have sine, cosine, but the angle switch, 3 pi over 2x, x 3 pi over 2. And since we're adding the angles here, we're going to add the products here. So with each of these, once you expand it out, you want to make sure you evaluate. Now, sine of 3 pi over 2, when you evaluate this, you get -1. Don't write sine again, right? We're not doing sine of -1. It's sine of 3 pi over 2. What is the y value at 3 pi over 2? It's -1. Now, x, we can't evaluate that, so that stays as cosine of x. And then we can keep going. You'll see that since this expression equals 0, this whole product cancels out, and we just get negative cosine of x. Okay, so a lot of, you'll see a lot of, or we saw a lot of problems in this chapter where we evaluated using our double angle, our sum and difference identities. We also saw a lot of expressions where we had to use our identities to simplify expressions. So we weren't evaluating, really, just simplifying. So the strategy, whenever you have a fraction, is to first rewrite it, split it up so that each trig function has its own fraction. So since the tangent's in the numerator, I kept the tangent in the numerator here. Since the sine was in the denominator, I kept the sine in the denominator here. And I multiplied those together because, as you see, if we were to multiply across top and bottom, we'd get the same expression. So this expression and this expression are the same. By splitting it up like this, we can rewrite tangent as sine over cosine. And when we multiply, we see that the sines cancel, we're left with 1 over cosine, which is secant of x. So we did a lot of verifying or simplifying expressions. You might see some of your algebra skills come into play with these types of problems. Okay. Back to our identities, we have negative angle identities. So with these, you can memorize these. Notice that for the negative angles, when you're going in the negative direction, whether it's positive or negative, switches, right? So sine of theta and then sine of negative theta have opposite signs. Same thing with tangent, because when you're going in from the first to the fourth quadrant, or maybe from the second to the third, or vice versa. Now, the only one that stays the same is our cosine. So cosine of theta or positive theta, both are going to stay the same. So your negative angles for cosine will stay the same. Your negative angles for sine and tangent will flip their sign. They will be opposite. With these, you can memorize, like I said, or you could just simply draw a picture and get the relationship that way. All right, we'll keep going. So the last type of problem we saw from this chapter was using the identities with multiple angles. So instead of knowing the actual angle measures, what if we only knew the characteristics of the angle? Well, first of all, you have to take what you're given, draw a picture, make sure it's in the correct quadrant, and apply the sign. So in quadrant 4, x is positive, y is negative. So make sure your x and your y are positive and negative accordingly. Okay, that's really important. If you mess up the characteristics and what quadrant you're in, the rest of it's going to be wrong. So be really careful with this preliminary step where they give you, like in this case, tangent of A is -4/3. When it tells you that tangent is negative, we're not really sure if y is negative or if x is negative. We have to know what quadrant we're in to determine that. So in the fourth quadrant, y is the -1. If sine is negative, that has to be the y, because remember, r is always positive. And then, of course, you'll see that our triples are coming into play. 3, 4, 5, 8, 15, 17. Make sure you guys know your triples. Once you know your x, y, and r characteristics for your angles, then we can expand using the identities and then plug in the values. Again, please do not write cosine of 3 pi over 5. That's not what we're doing. Cosine of angle A wants x over r, 3/5. Cosine of angle B wants you to look at B and take the ratio x over r. So once you evaluate, you should not see cosine or sine in the second line. Instead, we're just going to multiply across the fractions, watch your signs, and then you should have common denominators here, so then it's just a matter of doing 45 minus 32. Okay, so this is just a sum and difference identity. The second one wants a double angle identity for 2 theta. So we don't know anything about 2 theta, but we know a lot about regular theta. So again, we need the characteristics of theta, and then we have to use the identity to get it in terms of just regular theta, because that's what we have our information for. So we plug it in y over y over r, x over r, and multiply through. And the last 2 problems here, we have more simplifying, verifying type questions. So again, utilizing our algebra skills. If we're adding with a fraction, we need a common denominator. So multiply top and bottom of this term by a fancy number 1, so that we get our denominator of cosine. And then since they both have the same denominator, you can combine them into one fraction, apply your identity. This is our Pythagorean identity to get our final answer. Number 39, we use the strategy of multiplying by the conjugate. When you multiply by the conjugate, remember that's kind of the form a plus b, a minus b, which leaves you with a squared minus b squared. Those should cancel out nicely, allow you to use a Pythagorean identity. In your numerator, however, you want to be really careful. Typically, for the most part, you want to keep, when you're multiplying across, things in factored form. Notice I didn't distribute this product into it. It kept it in factored form. You want to do that in the beginning to see if things cancel. Now, if nothing cancels and you get stuck, then go ahead and distribute and see what happens. But for the most part, something should probably cancel, and then you can distribute to get your final answer. Okay, so there was a lot of information from this chapter. There were only like 9 questions that we did for review, but a whole chapter that you should have studied last night. So you have a couple minutes. Look through your notes packet from chapter 5, your identities chapter. Look through your worksheet packet from chapter 5. Study, review, make sure you know your identities, and then good luck on your mini quiz. We'll see you guys tomorrow.